All right. Good morning, everyone. Today's session is on Aurora PostgreSQL for SQL Server DBAs. So this is DBA focused session, but if you still have any questions related to development, you still can ask any question related to comparing between SQL Server and Postgres. Okay. And before heading on to the session, a quick introduction about myself. My name is Chandrapati Wada. I'm the database specialist solution architect, focusing primarily on commercial to open source migrations. That includes SQL Server or Oracle to Postgres or MySQL.
And I'm Twimi Tran. I'm a database specialist solutions architect as well, and my focus is on the AWS database portfolio.
Thanks, Amin. And the agenda for this session is first, we will go through a level 200 on Amazon Aurora overview, and following with high availability, backup restore, DR, scaling, security, and performance monitoring, and the migration options available to migrate from SQL Server to Postgres. Okay. Right. So why Postgres, especially why Amazon Aurora? Because it's Postgres itself is compatible with MySQL and Postgres. Aurora is compatible with MySQL and Postgres. Okay, we have two types of Aurora. You can spin Aurora MySQL or Aurora Postgres. And since it's an open source, you no need to pay for the licenses. You only have to pay for what you use. Okay. So that's a major benefit, and this is what driving most of the customers to choose Amazon Aurora, since it's built on open source database. Right? And it gives throughput and availability of commercial databases, which I'll cover in the following slides. And you only pay for what you use. That includes storage, I/O, compute, backup, and all these things. You only pay for what exactly you use in Aurora Postgres. Right? Yeah. And let's look at the Aurora architecture at a very high level. So in some of the on-premise environments, the storage and compute is coupled together. And the problem with this coupling architecture is if you want to upgrade your database, then you have to upgrade your entire storage along with your compute. But on the cloud in general, the storage and compute are always decoupled. Okay. So here, the main advantage of this decoupling architecture is just in case if you want to upsize your compute, then you just have to spin in different instance with whatever the size that you want for your workload and reattach to the same storage. It automatically reattaches to the same storage. You just have to upsize or downsize whatever the instance based on your workload. Okay. And the second major advantage is, just in case if the compute instance, if it fails for any reason, then behind the scenes, it spins up in another instance and it reattaches to the same storage. Okay. So that's a major advantage of having this decoupling architecture. Okay. And so here, the major benefit of Aurora Postgres, and even if you compare with the standard ODS Postgres, is its storage. Primarily, it's storage. Because Aurora is a log-based storage, and it takes copies of each write. So here at the bottom, you see this is the storage, okay, and here you see the small nodes, and these are all the compute nodes, okay. And when you write, let's say if you insert one record, then that record goes to 3 availability zones, where it takes 6 copies of each insert and keeps 2 copies on each availability zone. So your data is always will be on 3 availability zones with 6 copies. Okay? And the quorum for write is 4. That means as and when it writes 4 copies of the data in any of these 3 availability zones, then only it commits. Okay? But the quorum for reads are 3. That means as and when at least a minimum of 3 nodes are available, then it allows reads. Okay, so quorum for write is 4, quorum for reads are 3. Right? And we also take backups continuously to Amazon S3 bucket. You don't need to schedule any backups in Amazon Aurora. And it's a log-based storage. I'll cover what is a log-based storage in the next slide. So this makes Aurora, the storage architecture of Aurora brings Aurora as an highly fault tolerant and reliable and highly available. Right? Okay. So let's look at the log-based storage. Okay. So how many of you are working on Postgres? Okay. And how many of you have background on SQL Server? Everyone, nice. And how many of you are aware of checkpoint? Okay. So let me review the checkpoint, okay. So let's look at the checkpoint on SQL Server. So on the left-hand side, you see checkpoint process on SQL Server, and on the right-hand side, you see the same checkpoint on Aurora Postgres, okay. Comparing side by side here. So here, if you issue an update statement, just an update statement here on SQL Server, then what happens is the data, the page where this data belongs to, okay? So this is in disk, the bottom is in disk, and SQL Server stores the data in form of 8 KB pages. So if you issue an update statement, then the page where this data belongs to will be copied to cache, will be copied to buffer, that means the memory. And then it copies the pages over there, and then it updates the page first, and then it immediately writes the transaction to wall cache following with a transaction log. Okay, so a transaction log is an L1 and L2. But here the thing is, okay, the page got updated, and the transaction is written to the transaction log, but this page data has to be hardened back to the storage, right? If it is not, then what happens is, if the power is gone or if you restart the instance, then all the data in this buffer will be gone, right? So there is a process called checkpoint that runs every 5 minutes, I think. Yeah, I'm not 100% sure the duration. Yeah, let's say every 5 minutes in SQL Server, there is a background process called checkpoint. The checkpoint process writes all the dirty pages, means the modified pages, back to disk, okay? But since it runs every 5 minutes, let's assume that it runs every 5 minutes, but what happens if you face any issues? It could be a software or hardware, or let's pick if the power is gone and the instance shut down, within that 5 minutes, let's say after 2 minutes, so the checkpoint didn't happen, okay? Yeah, because there is a problem with the checkpoint. But your data is in the buffer, in the memory, then the data is gone, right? So when you restart SQL Server, in the SQL Server logs, you will see a message. The message says that, okay, SQL Server is recovering the pages which are not yet written back to the disk from the log, from the transaction log. That process is called recovery, okay? So if you look into the step 1, 2, 3, and 4, and this 5 only happens when you restart SQL Server, right? So if you look into till the step 4, till the checkpoint, what is the most resource intensive step out of these 4? Let's assume that you have a highly volatile, busy system with thousands of transactions are inserting and updating, right? Then in that system, the checkpoint is the most resource intensive process. Why? Because it has to copy all these modified pages in one go to the disk, right? So sometimes that causes some disk contention too, right? Yeah. On SQL Server, there is no way to delay the checkpoint, because you cannot directly delay checkpoint, because if you delay, then what happens? Instead of 5 minutes, what if I delay this checkpoint to 30 minutes? Then for 30 minutes, if something goes wrong after 10 minutes, then it has to recover 20 minutes of data to this data file, right? So your recovery time will increase. So SQL Server doesn't have any direct way to delay the checkpoint, but indirectly you can delay checkpoint by setting the recovery time interval. Okay. So if you set the recovery time interval to, let's say, 30 minutes, then the checkpoint happens every 30 minutes. So indirectly, you're configuring this, and knowing that your recovery time will increase at the cost of, at the cost of delaying this checkpoint. That's a way to configure in SQL Server. Right? Yeah. So this is still SQL Server 2022. I don't know whether if there is any feature that is released to configure the checkpoint directly or not, but this is what the existing architecture in SQL Server. Okay. Any questions still here? Okay. So now let's compare the same transaction what happens in Aurora Postgres. So this checkpoint process, by the way, this checkpoint process is common with the native Postgres. If you look at the native Postgres, it is the same steps, same configuration, okay, no difference. But with more options on native Postgres. The more options is in Postgres, you can actually stretch this checkpoint. Or stretch means instead every 5 minutes, you can configure, stretch it for 10 minutes. Then it actually stretches. So instead copying all the data pages in one go, it actually copies half the pages and then stretch rest of the pages in the next 5 minutes, something like that. Okay. Yeah. So now let's look into the Aurora Postgres. Here I'm comparing with Aurora Postgres, not community Postgres. Okay. So in Aurora, you're issuing a same update statement, but what happens is it directly writes a log record over here. Okay. And then it hardens that log to storage. Okay. So in Aurora, the primary Aurora storage is a log-based storage. Okay. Yeah. But it's a log. So for an update or insert statement, it writes to the log. But to read the data, you need it in the form of a page. So behind the scenes, what it does is, at the background, it continuously recovers the pages over here. Okay, so this continuous recovery, just like this, will happen in SQL Server, will happen in Aurora Postgres. And we also take the continuous backups of these logs and pages to S3 bucket. Okay. So if you compare the left side and right side, what is missing on the right side? It is highlighted, no checkpoints. In Aurora, there are no checkpoints, which is some resource-intensive process for some of the workloads, for the write-heavy workloads, right? So that makes Aurora 3x faster than the community Postgres. Okay, this checkpoint, that's the main difference. Okay, and we take the backups continuously to Amazon S3 bucket, and I'll cover backups in the next slide too. Okay. Any questions so far on this? All right. Okay. And now, so this distributed storage provides a redo log processing because it's a continuous recovery, what you have seen in the previous slide, and an instant crash recovery. That means if any database, you pick any database in general, if it crashes, then most of the time, what the database spends is for the recovery process. But since it does a continuous recovery, it recovers your database system instantly without spending much time because it's a continuous recovery, right? And fault tolerant and self-healing. Self-healing means, as shown in the previous slides, sorry. Okay, self-healing, I'll cover it in the next slide, but yeah, it's a fault tolerant. That means you have one writer and multiple readers, and if there is an issue with any of these writers, first it tries to restart writer, and if that doesn't fixes it, then it will fail over to one of the readers. Okay. And fast database cloning, that I will cover in the next slides. So all these options I'll be covering in the next slide, so which includes database cloning, snapshots, backups, scaling, and read scaling, and warm cache, and the rest. Okay. So let's look at the high availability and disaster recovery. So here you see this storage, right, where it copies data across 3 availability zones with 2 copies on each availability zone, right? So even if, and the quorum for write is 4, so even if one availability zone is down, it still allows the write operations, right? And so here, this is the storage, and this is your compute instances. Let's say by default it comes with a writer, and if you spin a reader here, then both writers and readers shares the same storage. That's another difference, because in SQL Server you had to configure a reader, and you had to set up always on or some kind of a replication to copy the data or to synchronize the data from primary to reader. But Aurora is a shared storage. That means all writers and readers shares the same storage. Okay? And in case, as I mentioned earlier, just in case if there is any issue with existing writer, then it picks one of the reader and makes as a new writer. Right? Yeah. And auto healing. Auto healing means these are all the storage nodes. And let's assume that if there is any issue with any of the storage nodes, then it auto heals by copying the data from the neighbor nodes in that way. Yeah. 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 So let's look at the disaster recovery compared to SQL Server. So I hope everyone knows about the SQL Server features related to disaster recovery that includes always on, clustering, mirroring, log shipping, and your backup strategy and rest. But on the Aurora Postgres, you don't need to configure backups or any of these things. With one push of a button, you can have a regional-wide DR using a feature called Aurora Global Database that I will cover in the next slide. But the features which supports disaster under DR is the global database, cross-region snapshots, DMS, and logical replications. The last two you need to configure, but the first two are already available with Postgres. Okay. I mean, with Aurora Postgres. Right. So let's have a look at the global database. So here, this is your primary cluster. And let's assume that you want a DR on a second region. Okay. Let's assume that this is US, and this is China, maybe. Okay. China or any other region. Okay. And you want a DR. So if you create a global database and specify the region which you want, then it copies your storage with a millisecond latency to the region of your choice. So your DR is available with a push of button. Okay. And using global database, you can have up to 5 regions, right? And you don't need to do any configuration, because all the replication between the regions, the data replication between the regions, that's an inbuilt, and that happens at the storage level replication. That will be taken care by the AWS itself. Okay. And when we talk about DR, then 2 things pops up. One is RPO, and second one is RTO, right? The recovery point objective, RPO. That means if you have an SLA that you don't want to, you cannot lose the data which is more than 5 minutes. So how to achieve that using global database? So when you enable global database feature on Aurora Postgres, you can configure RPO with your SLA timing. Let's say if I configure RPO as a 5 minutes, then what happens is, if my RPO is 5 minutes, then if there is any delay which is more than 5 minutes, a delay in replication between these 2 regions, and if that delay is more than 5 minutes, then what happens is it stops the traffic from the application because of the delay. Okay. Because there you give preference to meet your SLA, especially to the DR. To meet that SLA, you can configure RPO using global database as well. Okay. Yeah. It is just a parameter. You just open Aurora cluster and mention the time that you want. RPO is equal to 5 minutes or 10 minutes based on your SLAs. Okay. Yep. And the second thing is, so here, this is the storage. Okay, this is the storage that it replicates to other regions. And here, these are the readers. You see 2 readers. Readers are nothing but compute instances. And you can have up to 15 readers on the secondary regions. But since we are talking about DR, why do we need a readers at the secondary region? You don't need it, right? Yeah. So these readers are optional. when you create an Aurora global database, you don't need to, it's not mandatory to create readers. You just have to enable global database and enter the region, and only your storage will be replicated here. So in what scenario you need readers? Let's say if you want to bring the data close to the customers or close to the applications which are near to this region, then only I need the readers. And then I can spin a reader and I can connect to the application. Okay. And the second, this I personally likes it. And the second major advantage of Aurora Postgres is this is not only readers. What if this app wants to write? Okay, both read and write. Since it's a reader, it cannot write, right? So there is a feature which we released a couple of months back that's called write forwarding. That means you still can issue write operations like insert, update, delete. Okay, except some DML like truncate table. You cannot issue truncate table, but but you can issue delete statement. Okay, so all regular DML statements you can issue on the secondary region as well. But since it's a read only, and you should not allow any write operations over here. So what it does is this feature called the write forwarding. If you enable write forwarding, then any write that happens on this instance, it forwards those writes to this region. And then it synchronizes the data. In that way it works. So when we talk about write forwarding, then you may think about, okay, how about the consistency or the latency? Because I issue one write over here, and it's forwarded that write to here, and again, it has to be available here to see my data, right? So there is a latency, right? So when you implement write forwarding, it comes with certain isolation levels. Okay, it supports 2 isolation levels. Hope everyone, it's just like SQL Server top 2 isolation levels, like the read committed and repeatable write. So these 2 isolation levels that it supports. So along with the isolation levels, you still can configure your consistency settings. Okay, with that you can achieve a strong consistency and you can reduce the latency as well. So some configurations are available to to achieve high consistency and reduce latency when using write forwarding. Yeah. Sure. Okay, that's a good question. So if you issue only one insert statement, then it forwards just that insert statement. Okay? But if you put a bunch, like a block, like insert, update, delete, and another insert, update, delete, then it forwards, then it makes that entire as a single block, and it go in a one transaction, not individual one.
But then the reads also then go to the.
No, the reads will be here.
But the read is part of it.
Oh, okay, I see. Okay, that's the reason. If you say insert into select star from some table, you're copying data, something like that, then the entire thing, the insert and select, okay, if it is a part of, if the select is part of insert, then the entire block will go to the primary one. Yeah. Or else you see some data inconsistency, right? So that's the reason we make it like as a complete block if you issue more than one statement. Yeah. Right. Yep. So now backup and restore. So let's start with SQL Server. So a traditional backup, what most of the SQL Server DBAs does. So we, in SQL Server or in any other database, we take weekly full backup and daily differential backups, and every 15 minutes or 10 minutes, we take transaction log backups, right? So just in case if there is any issue happens on Thursday morning or Wednesday night, then the steps to recover this database is, first we restore full database, the recent full database, following with recent differential, following with all transaction log backups, right? But it takes some time. I mean, the duration it takes to recover the database is primarily depending on the size of your differential backup. I mean, the size of your full and the size of the recent differential backup, right? And now let's have a look at our backups. So here in, okay. So here in Aurora Postgres, Aurora does a continuous backup. Okay, it takes continuous backup. You don't need to configure anything, and it's a continuous auto backup. Oops. Okay, okay, it's a continuous auto backup. Okay, sorry, I have to move this to here for some reason. Okay, so for this auto backup, you can have for 31 days. Okay. And by default, if you don't configure auto backup for 31 days, then by default it comes with 1 day full backup, 1 day auto backup. Okay, you cannot disable that 1 day auto backup. It has to have at least 1 day full backup. Okay, and till 35 days, it's incremental in nature. All the snapshots are incremental in nature. That means, let's say if you have your database size is 10 terabytes and your backup size is 10 terabytes. Okay, and first day you take the snapshot. Let's assume the snapshot size is 10 terabytes. But on the next day, the snapshot size is, let's say, same 10 terabytes because there are no changes at the database. Then there is no charge. And the following day, it's 11 terabytes. Then you'll be charged only for the extra 1 terabyte. In that way it works. Okay, so you'll be pay for what you use. Okay. Yeah. And you can also take, if you want to retain backups for more than 31 days, then you can take manual snapshots as well, as a manual backup, and you can retain as long as you want. Okay. And you can also copy these backups to across the regions, because if you want to have a cross-region DR, then you can configure these backups to copy to other regions. Or the simple way to do, if you want to have a cross-region DR, is to just enable global database. If you enable global database, then your storage will be replicated to other region, and you still can configure the RPO setting over here. Okay. Now on scaling and optimization. So on SQL Server, you have replication, in always on readable secondaries or replication, right? But on Aurora Postgres, we have more. We have up to 15 read replicas, and the storage. As I mentioned, the storage, you can scale it by upsizing or downsizing based on your demand. And you can also configure auto scaling for read replicas. Because here you can have up to 15 read replicas, right? But you don't know your workload. Like, I mean, let's say if you configure 2 read replicas, but during the peak hours, you may need 15 read replicas, but you don't know the load. So you can configure this auto scaling configuration on the read replicas based on the compute and the memory consumption. Yeah. So you just have to enter the thresholds, and based on the threshold, it automatically creates number of read replicas. And when it goes below the threshold, then it automatically deletes the read replicas. So auto scaling is available for the read replicas. Okay. And along with that, we have serverless and global database readable cluster, as we covered in the previous slide, and a self-managed logical replication that I'll cover. Yeah. And fast clones. So here, if I compare with SQL Server fast clones, hope everyone knows about SQL Server snapshots, right? I'm not talking about AWS snapshots. I'm talking about pure SQL Server snapshots. I think starting SQL Server 2008, Microsoft introduced snapshots. That means you can take a snapshot of a database. So let's assume if the database size is 10 terabytes. And if you take a snapshot, then your snapshot, you can quickly create a snapshot, because the snapshot won't take the copy of the 10 terabytes in SQL Server. It only creates a sparse file with just 0 bytes. And after the snapshot, any changes that happens on the main database, it only copies the modified pages to the snapshot location. That's how SQL Server snapshot works. Yeah, I just explained SQL Server snapshots because I want to compare with Aurora Postgres. Okay. In Aurora Postgres, just treat the Aurora Postgres fast clones is somewhat similar to SQL Server snapshot. Okay. So here, this is the storage. Okay, this is the primary storage, and I have one writer one writer and one reader. And I had two applications. One application connects to my writer, and then another application is using this compute instance for read transactions. And I have one reader. Okay. Now, my downstream departments, let's say my analytics department wants a copy, or a development department wants a copy of the database. But my database size is, let's put 100 terabytes. Now they want a copy. So here, using fast clones, you can quickly give a copy of your database, and it only takes few minutes. It takes even less than 5 minutes. And this is how it works. So if you take a clone for a reporting application, let's say, okay. So this is your clone. Okay, this is your clone instance, which allows reads and writes as well, because this is a copy of the database that you want to give, right? So what happens is, when you create a clone, then the clone attaches, the clone creates, so this is the clone storage. Okay, this is connected to this, okay? But here you see the blank boxes. That means these are all the virtual pages, okay? So when you create a clone, it only creates virtual pages, points to the actual data pages in the primary storage. So if you issue any reads, then all the reads will be redirected to primary storage. So it no need to copy the data, right? But what about writes? What if you issue, let's assume that you create a clone at 1 p.m. and you issue a write at 2 p.m., means one insert or an update, okay? So during that time, what happens is, since this clone should contain the data at the time when you created, which is at 1 p.m., it only, at that time only, it only copies the page, okay. It only, let's assume that you want to update the data on a table, which is on this particular page, then it only copies that page from the primary storage to clone storage, and it modifies the page over here, so that you have your updated data on your clone storage, okay? So this process is called copy on write protocol. That means it only copies the data as and when you write any page on primary or secondary, okay? So if you look into this architecture, then you can pick the primary use case. The most common use cases for clone is, let's say if you want to give a copy of a database to analytical or downstream departments, that includes the risk, analytics, or the developers, for a shorter period of time, then you can create a clone. Here, why I mentioned shorter period of time is because if yours is a production highly volatile application, database, which has large number of writes, then when you create a clone, for every write, it has to copy the page from here to here, right? Right? So if you create a clone, then you see some I/O between primary and secondary, right? So use this clone only for the shorter duration of time, let's say for a day or 2 days. And the use case is, once the analytics team or the reporting team, once they analyze that particular the data for that particular day, create a clone, produce report, and drop the clone. And don't keep the clone for longer durations. And the other use case is, let's say you want to test your application with the next version of Postgres. Then you can take a clone. You can take a clone of the Aurora Postgres, and you can upgrade it to the next version. You can test your application. So that's another way to. That's another use case. Okay?
So you're saying that the difference between SQL Server and Aurora is Aurora is continuously taking those new pages and adding them to the pointer clone storage.
Yeah, only the pages which are modified after the time at the time when you created the clone, not all the pages. Yeah, yeah. Right. All right. Yeah. So sorry, this animation. Okay. So it only copies the pages which are modified after you created a clone. Okay. So here are the use cases that I mentioned. So for any pre-prod, or if you want to implement a blue-green kind of an environment, okay, then you can take a clone and you can implement change data capture between the primary and secondary instance. But again, you don't need to even do that because we released another feature 6 months back that's called blue-green deployment. So blue-green deployment is another pretty interesting feature. So using blue-green, let's say if you have an Aurora cluster, and if you want to create a green environment, then you just have to click a button, and it creates a green environment. That means it creates a copy of the data, and it continuously replicates the data between primary and secondary. So you make the changes on your secondary. Either you can upgrade your database or make any kind of an application changes on your secondary database, okay? Then failover to secondary, then failover to green. And after the failover, the green will become blue. So you don't need to manually configure this clone and configure the CDC, okay? Prior to blue-green feature, this is how some of the customers are doing this. But now, since we released the blue-green, you can use that feature. But behind the scenes, blue-green uses clone to take an initial snapshot. Okay? Yeah. And clones, you can create up to 15 clones. And let's say if you want to make the clone as a standalone instance. Because here, if you look at the previous slide, the clone has only virtual pages, right? So you won't be charged for any of this because this is blank. You only charged for what you use, only for the pages which are copied, right? So if it is a read-only database, especially, then you'll be charged only for this, not for this. Okay? Yeah. Yeah. Okay. And yes, you can make the clone as a standalone instance, and you can make it like as another writer too. Just in case if the dev team wants a copy of the database, then the fastest way to do it is create a clone and convert the clone as a standalone instance and give it to the dev or any department if they want to use it for the longer period. Okay. Right, and security. So on SQL Server side, we have SQL Server authentication, Windows authentication, or mixed mode authentication. Right? But in the Postgres, compared to SQL Server, Postgres has Postgres native authentication. And here in Aurora Postgres, you can have IAM authentication, okay? And Kerberos authentication, like in SQL Server. And another major feature is you can also integrate with the AWS Secrets Manager to manage your credentials. That means you can create a username, password, and all these credentials will be in the Secrets Manager, and you can integrate with the Aurora Postgres. Right? Yeah. And encryption. Okay, SQL Server, just like in SQL Server, it starts with SSL, and after that, TDS, TLS, SQL Server always encrypted, right? So, like in Postgres, we also support 256-based encryption and TLS. And also AWS KMS. KMS is you can bring your own key to encrypt the data. Okay? And we also support PG Crypto extension. So using PG Crypto, you can mask the data with your choice of your key. You can use 256 is the most common one. And using that, you can encrypt the data using an extension called PG Crypto as well. And performance monitoring, I think SQL Server, by default, SQL Server comes with perfmon and inbuilt DMVs and extended events. And I think it also comes with a kind of a dashboard monitoring, SQL Server, right? Yeah, but on Aurora Postgres, since it's a managed service, it comes with several monitoring tools. Starts with CloudWatch. CloudWatch is to see if there are CloudWatch is to see the resource usage at the cluster level. That means at the compute, memory, storage IO, all these metrics, you can see it in the CloudWatch. But if you want to see what is happening inside a compute instance, let's say the compute instance is nothing but a virtual machine. It's like as an EC2 instance. And if you want to see what are all the processes that are running within that instance, then you can go with an enhanced monitoring. Okay? And the major, when to use CloudWatch or when to use enhanced monitoring is, see the first, always pay attention to CloudWatch because the CloudWatch will give a lot of alerts, right? So let's say if your CPU is more than 90%, then you can get that alert from the CloudWatch or the CPU memory because that's the first level to look at it, right? And after that, if you want to dig into why this is happening, then go with an enhanced monitoring, okay? Yeah. And performance insights. Performance insights that gives a performance insights feature that's available at the console itself. So using performance insights, you can see what are the top 10 most resource-intensive queries. And you can also see the weight stats, like SQL Server weight stats. Okay. Here in Aurora Postgres, you can see the top 10 weight stats related to disk sync IO or the parallelism or the memory or any weight stats. You can see it using the performance insights. Yeah. So this is a pretty handy tool because most of the DBAs are developers. First, they look at the performance insights and they can see what are the top 5 most resource-intensive queries, and then the next step is to pick that query and do further troubleshooting. And Aurora Postgres also comes with few statistics views. One of the most common view is PG stat. All views in Postgres starts with PG_stat. Okay. So the most common view is PG stat user tables. And using this view, you can see the list of all the tables in your database and how many rows in this database. And when was the last time the vacuum ran on these tables? And when was the last time that the statistics are updated on these tables? So the entire health state of your tables, you can see it in one view. That's a PG stat user tables. So along with that, there are some other views as well, okay? Just like is in SQL Server. And also provides logging options, okay? Like in SQL Server. Yeah. Okay. So this is an snapshot view of the performance insights. So here you can see the database load, and these are all the weight stats next to that. And at the below, you can see the counter matrix. So here the thing with the performance insights is there is a feature that we added like a couple of months back. So at the performance insights, you can see both CloudWatch metrics and the performance insights metrics together. That helps you to diagnose what is causing this particular query to wait for a particular event, because you can see, you can correlate between CloudWatch and performance insights. Yep. You want to add anything on performance insights? Or?
No, I think you covered it all. Yeah.
Okay. And the performance insights, it's free, okay, for first 7 days. So for most of the troubleshooting, 7 days are mostly enough, right? Because you react within next 24 hours or based on the criticality. So keep it for 7 days because it's a free. But if you want to retain for more than 7 days, then you can increase it, but there will be charges after 7 days. Okay. And migration options. A quick time check once again. Yeah. And migration options. So to migrate from SQL Server to Postgres, okay, let me ask a quick question. So how many of you done any migrations from SQL Server to Postgres? Have you ever involved in migrations? Okay. So to migrate from SQL Server to Postgres, it takes 3 steps. I'm talking about a very high level. Okay. So the first step is take the copy of your schema, that means your tables and the data types. Okay. And then Postgres supports 90% of the data types what SQL Server supports, up to 90%. Okay. There are few differences on Postgres, very few differences, but majority of the data types it supports. So that's not the major challenge. And copy data from SQL Server to Postgres. We have AWS DMS, or you can pick any native tool. You can export the data using BCP from SQL Server, and import the data to Postgres using copy, or use some ETL tool or some other third-party tool. So migrating tables and migrating data is not major challenge compared to the third one, which is migrating your source code, which is your views, functions, triggers, stored procedures, all these things. Especially migrating stored procedures and functions is challenging. There you have to spend a lot of time, right? So we have a tool, okay? Before heading into the tool, so we have a tool which is called SCT, AWS Schema Conversion Tool, which is a free tool. So you just have to download AWS SCT into your laptop and connect SQL Server database and specify your target engine. The target engine could be MySQL or Postgres. So if you specify target engine, let's say in this case Postgres, then it automatically converts the source code from SQL Server to Postgres up to some extent, because it cannot convert every single thing. Because especially if there is any gaps in any functions or any patterns, then it won't convert, but it highlights. It highlights as a potential blocker. But that SCT reports will give some ballparking estimates. Based on that, you can assess how much effort it takes to rewrite from SQL Server to Postgres source code. Okay? But what if there is a database which is built on Postgres, but behaves like SQL Server, so that you don't need to rewrite your source code? It is as if like migrating from one SQL Server to another SQL Server. So what are the steps to migrate from one SQL Server to another SQL Server? First, you take the schema, extract the schema, and execute the schema at the target SQL Server, and copy the data, and copy the stored procedures. As simple as like that. So that is that product is called Babelfish. So we have a product called Babelfish. It's called Babelfish for Aurora Postgres. And Babelfish for Aurora Postgres behaves exactly like it's in a SQL Server. Okay. But it's built on Postgres, so you don't need to pay for any licenses. And if you connect through TDS endpoint, that means if you connect Babelfish using SQL Server Management Studio, then it behaves like SQL Server. But the another advantage is it's a kind of a hybrid database. That means if you connect using SQL Server, then it uses the SQL Server space, the SQL Server libraries within that Babelfish, and it behaves like SQL Server. But if you connect using a Postgres endpoint, then it behaves like as in Postgres, because beneath that there is a separate databases separate database space for the Postgres. So you can start building, you can start migrating your native SQL Server applications to Babelfish without rewriting your source code. And you can also use the Aurora Postgres, Babelfish for Aurora Postgres to develop your new applications using Postgres endpoint. That's a major advantage. But the question is, okay, if that is the case, then I have 100 SQL Server clusters, so can I migrate everything to Babelfish? Yes, if it is compatible. If it is compatible with Babelfish. Because here we are not trying to replace Microsoft SQL Server here, because Microsoft SQL Server has been for more than 3 decades, and it's a very powerful database. And I'm a SQL Server DBA for 15 years. And it's not meant to replace the entire SQL Server. That means Babelfish it doesn't have SSIS, SSAS, SSRS integration with some other clusters and all these bells and whistles that comes with SQL Server. Babelfish doesn't have. Babelfish only supports T-SQL. And just T-SQL with the tables, views, functions, procedures, triggers. No, the entire schema, like that. Okay. Yeah, so it's worth trying Babelfish. But again, how to know if my SQL Server database is compatible with Babelfish? So for that, there is a tool which is available at GitHub. It's called Compass. So download that Compass tool, and using one click of button, you will get an HTML report that tells whether your source database is compatible with Babelfish or not. So based on that, you can make a go or a no-go decision, whether to choose Babelfish or not. If Babelfish is not compatible, then you have other options to migrate to AWS. That includes either you can start with RDS on SQL Server, RDS SQL Server, or SQL Server on EC2, or if you want to, or if you can spend some time and effort to migrate to Postgres, then you can use schema conversion tool and you can rewrite to Postgres. Yeah. So we have even more options are available. So you can stop by at our AWS booth to learn more about how to migrate SQL Server databases to Postgres, okay, or even how to modernize your database. So there are some couple of sessions even today after 2 p.m. At our booth. You can stop by to learn more about migrating and modernizing. Yeah, with that said, thank you so much, and thanks for this opportunity. And if you have any questions, then please let us know.